Okay, so I'll set this up real quick. We are creating the first part for today. There's a couple things that we need to be doing in terms of creating this part. There's also a couple gotchas that probably a number of you fell for. So we want to start on the right plane. We want to start with the base geometry, which in this case is a rectangle. Get our smart dimensions. And we are A, which in this case is 50. And B, which in this case is 70. Okay, 50 by 70. All right. Then we've got a couple assorted details. All right. How many of you are already seeing where you might perhaps have made a mistake? We want a circle. We want this to be 27 from the back edge. Let's see. Yeah. 27 from the back edge and 27 from this edge. Not bad, pretty close. Okay, we have a couple details where they didn't exactly give you the information right about here. So you have some kind of point and then some kind of point on the circle. Nope. Some kind of point and some kind of point on the circle. There we go. Got to make sure that you make those associations. You'll find out why here in just a little bit. There's a couple other ways that you could go about doing this, but this is going to be easiest. Make sure you get both of those associations. So each of those points should have a couple things. Now we can move those up and down freely as we need to later. There's also the matter of this little rectangle up here. 3.3. Pretty close. 3.3, 29. Okay, that goes all the way through. We also want to do one more because this one has a diameter of what? 38. I'm going to set the diameter of this one as well. This one is I think it's on that same one. No, it is not. Oh yeah, it is. It's right there. 40. 38. We'll go over the designations as far as what those things mean and how those impact life on this planet here in just a couple seconds. Yeah, 12 and a half. Okay. 38. So they give you a lot of actually really important detail in the descriptions. We'll come back to where and why that is, and why that makes a difference. So this smart dimension between these two, smart dimension between these two needs to be 19. And I think there was one other key to this. Nope, not necessarily. All right. So this, the way they have it set, it actually should be roughly at the center line. So this should be at 19/2. So I'm going to go ahead and center those because of the reasons. Then we're going to come back in and we're going to trim entities. So we don't need that. We do need this. Yeah, we're going to leave those two and you'll see why. And we're going to cut that one. Okay. That should be all for our first base sketch. So then we do our extrude of this region and this region. And we do this for 67 millimeters. Anyone identified a mistake or a misstep already? All right. This. So we're going to do the through hole in the top because that one's super quick and easy. I'm going to change views. So we'll do center line. That way we can say at 8.3. Okay, smart dimension. We're going to move this by pretty close, 8.3. And we're going to set up our circle. So this intersection that needs to be 6.3 millimeters. It's pretty close. It's almost like I know what I'm doing. That is going to be a through cut. But you want to make sure not to do a through all. That would be a very significant mistake. You're actually going to use up to next instead of being a through all cut. Whole bunch of reasons why. And we've got our C channel cuts. So we're going to do one more extrude cut. And there's a couple ways to approach it. The simplest, based on the dimensions that were given, is going to be from sketch 1. We're going to do an extrude cut, but we're going to do an extrude cut of this region. So that sketch region, and we're going to do that from an offset. That offset is going to be the 12.5 millimeters they give us. 12.5 millimeters. And it's going to be blind for 1.5 millimeters. Now, that gives us one cut. Then we're going to do another one that is going to be same kind of idea. It's going to be from sketch 1. It's going to be specifically of this region. We're going to do an offset of, instead of 12.5 millimeters. We're now going to do 67 minus 12 and a half. And we're going to do the same thing, except we now need to reverse the direction of this to get the center of mass just so. Okay, there we are. So now we've done our super complicated cuts. The only thing left is the stuff on the back. Now, this is where most everybody falls for the gotcha. So we're going to do a sketch. We're going to do it on the back face. We're going to reset our view. And a bunch of people go to create these. They use a center line as a reference. So we're going to use center lines as well. And then we're going to create our lines, making a reference to those center lines. So we're going to make a couple regular lines. And the exact details don't really matter here because we're going to set these up with the correct dimensions. Anyone figured out where their mistake on the mass was yet? Okay. Now we use our smart dimension. The distance here to here is what is actually 9.6. No. 0 degrees. Zero degrees. And now that those are parallel, we have a separation distance of 9.6. I'm going to make this a driving dimension. You can always move the origin later. First thing I have to do is get rid of this dimension. Second thing I got to do is set this, the position of the object right now. I have the corner here at the origin, this back corner. I don't remember if that's correct for what it needs to be for center of mass or not, but in this case, we're not actually going for center of mass. So now that those two are parallel, I'm going to set the distance again to 9.6. Leave this driving 9.6. Violate some laws of physics real quick. No biggie. Delete our second reference. Then we set our halfway distance to first make sure those lines are parallel. Okay. Then delete that reference so we can make a move. No. Okay, then delete that reference. Now that those are square to each other, we can then come back in and make a distance reference that is exactly half, which is the 4.8. So it's important to know that the distance reference is not 9.6 between that corner and this point. It's actually 9.6 between those two lines. That's where a lot of people got really, really confused. It's 9.6 between the two lines. So that's why this dimension is so important. So here again, close but no cigar. Needs to be exactly 180. Now I need to delete that reference. Then once it's square, I can come in and do the distance at 4.8. And there we go. Now, the only thing I need to do is connect these. Actually, the easiest way by far is to just do this. And come in, do the final trim entities. Now that everything's square, because we need one open region. All right. Okay. Now we have a couple of those leader lines in there. We don't need the deselect tool. We stay fully defined in the sketch. And we do our extrude cut of this interior region in about 1.5 millimeters, just like so. And we have created our part. So we go back up, double check our what our material should be, AISI 1020. So we set this up. Should just be the default AISI 1020. Normally they'll specify now that it has the right density. We'll just we'll assume that I've done everything else correctly here. And what we've got is this. So now we look at evaluating mass properties. So our overall mass should be about, based on those dimensions, and if the 1020 is correct, then we should have about 1220, which is interesting. So I'm going to double check a couple of our dimensions here, because I think I remember D being the correct answer for this one. But with A at 50, yep, B at 70, this at 67, the two diameters. Yeah. So dimensions of this one are correct. They may have updated this material. So let me double check, because the 38, so there's a difference between these two. Let me check this base sketch to make sure that that didn't get entered incorrectly. 34, oh yeah, so 38 is wrong. 38 is the interior. It needs to be, hold on. This 38 actually needs to be 40. I think I had to do a step back because that's incorrect. And then one more, that 34, 40 is correct. No, 34. That needs to be 38. All right, there. So that will significantly reduce our mass. Let's go back and double check. And there we are at 1127 in my 1129. They say 1127. So yeah, 1129. So that one's actually quite accurate. The difference is going to be in the positioning of those two cut lines. and where those are. So if those two cut lines are exactly defined, if you move them just slightly, and you don't quite center them, you change the amount of mass that's in this object. So you can get really close. They have a slightly different position then. So, all right, that's part one done. So you guys think you got part two all figured out? Let's find out. In the meantime, any questions on this one? Okay, rectangle on the right side as a starting point. That's a good one. What else? What other things should we be thinking about? How much of the detail are you trying to capture on that right side when you go to do this process? Let's bring this back up. I'm going to move this over so I can see it. All right. So big features. Yeah, I see they gave a couple of the key dimensions on this top part. So we're going to do right plane. We're going to work from the right side. And the simplest and easiest starting point is a rectangle. Since this one, we're going for the mass in total. It matters a little bit less where we set this up. So our overall total length is 100. Close there. Our overall total height, 63. All right. So there's a bunch of different features that we want to try and characterize here. One is we have a block taken out. And that is come on now. There we go. 40. And the depth there is 15. Okay, so we have a big chunk taken out there. We have an arc and a line. So we have a line somewhere here. We have an arc. See a little magic trick I did there. I'm going to use this one just for funsies. They give, that's a little better view. Yeah, it's a little better view. This one, it's going to be too much work to get that one to work. So I'm going to start with and we need an arc and we need another line. So that one, we want to set a couple parameters. So 225 is actually correct because reasons. That one needs to be 20. And that needs to be 10. Now the whole distance needs to be 40 with the distance between here and here being 15. Now, what they don't specify is they don't specify, for instance, the distance between these 2 points. So they don't specify the length of this line. And that's one of the areas where you have to use kind of best estimation. And there's a whole bunch of reasoning behind that. So they have a couple different reference points to that 45-degree angle. You could do a fillet of the 2 lines, and we can take a look at what that would look like instead of using a curve. So that's a reasonable option. So if we were to delete that, blah, 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 and we were to bring the length of these lines farther, we were to just bring them to intersection, make those coincident. You could do it this way, and that's not an unreasonable tool to use for this. And it might actually be faster than defining a curve. So at 10 millimeters. So that may be how they created it. The point being, because they don't specify an origin, you're going to have to use creative techniques very much like that in order to get to the end result that you're looking for. So we can go ahead and trim this out while we're here. And we're going to go back to our arc tools. For this. And what do we need for this one? We need center line info. We have a couple. One is a radius 30, one is a radius 25 at a 35 height. So here is where our center point arcs are going to come. And they're going to go essentially all the way up to here for now. So we're going to do 2 of them. We'll come back and trim what we don't need later. First step is to set the dimensions here to be 37. So it's pretty close there. 35. And then this first radius would be 30. So again, pretty close. Second radius, 25, again, pretty close. All right. We also have a couple of circles that are, let's see, do they give us centerline data for that one? Yes, they give us some. So right at that same height of 35, we're going to set up a center line because that's going to help us locate some things. So that center line is what's going to allow us to set a couple of things. Now, that arc actually turns out to be the point for this radius, for this particular object. So we have a pair of circles there. We also have another circle here. So this one has Some specs we need to pay attention to. 10 and we have our height there determined by 35. This is a diameter of 10. So they're again pretty close. This is a diameter of 10 again. This is a diameter. They give a radius for that since it's curved. Nope, they give a diameter of 20. Okay, so we've got a couple of those parts. That one gets trimmed, but not yet. So that becomes a vertical line from here to there. So now we start trimming away some of what we don't need. So that goes away, that goes away, that goes away. That one goes away, yes. Blah, 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 blah. That goes away. That goes away. This goes away. Yep, those two stay for now. This goes away. This goes away. This goes away. That stays because reasons. This goes away because extra confusion. We need to leave some of the geometries in place because we're going to need to create a couple kind of unusual features, but that's okay. There's also this larger circle as a whole. So we're missing still one of them. This one has a radius of 50, or has a diameter of 50. Okay, so we're going to come back to where some of these things get used. This allows us to do some trimming. So this, for instance, goes away. This goes away. That goes away. Now we'll have our recess cut. We'll do the through all holes elsewhere. That, I think, is 90+% of what we need, all in that one cut. One more. So we have a rectangle, and this one, for the sake of speed, we're going to create it using that one looks like it's going to be about maybe a 20 by looks like it's going to be a 20 by where do they give a radius of 10? No, a radius of 20 based on the diameter. Okay, so they give kind of a key piece of information on this drawing, and we're going to use a center point arc to set up one point. And what that's going to be, so we're going to do a 90-degree arc and then a line coincident with that and horizontal. The difference is we need this radius to be 20, and we therefore need that distance to be the 20 that it would be, which is established by our arc length here. So Yeah, that's exactly what we need for that part of the sketch. All right, so I think we've got all of our detail here. I'm going to reset the view. We've got all of our arc detail. We're going to do an extrusion. Now, we're going to extrude the whole length or the whole width first. We'll see why. It's going to be, yeah, it's going to be a lot easier just to do a quick cut from the top and do some of our other geometric work from a top slice instead. So this, we're going to use a few of the geometries. We're going to use this region, this region, this region, this one, this one, this one. You could do a series of extrusions to get everything you're looking for. I'm going to not include this one at first. I'm going to also not include this one at first. So what this is going to do is get us part of the geometry, and I'm going to bring that forward. How far forward are we going to go with that? 20, what is that depth? What is that second depth? We have, let's see if there's one more. So I'm just going to do the whole width, I think, and we'll come back and do a couple other features. So 50 millimeter total extrusion is what we're going to start with as our base part. Now, this gives us most of the detail. We're now going to do some extrude cuts. And there's a couple ways that we could do that. The approach that I'm going to suggest is I'm going to do one more extrude. I'm going to go back, reference that base sketch. I'm going to select this contour. I'm going to go from this surface, switch direction, and that will be my 8 millimeter thickness. So 8 millimeter thickness. And the 8 millimeter thickness also applies to this part. So I'm going to add a couple more regions here. So that way this part is being created from the opposite direction because I need to add that material. Most everything else is all going to be taking stuff away. So this one's going to be a pretty easy one. And the depth is going to be the same for all of them. No, it's not. Okay, so we're going to do a couple stages. So extrude cut, we're going to do this region. And this is going to be 9 millimeters worth from surface, which will be this face. So 9 millimeters worth on that first cut. It's possible to do multiple depths of other things, but it gets to be harder than what it needs to be. So don't try and do 18 different depth cuts with the same operation. Just do multiple as a general rule. So this will also be from surface. It'll be from this surface. And this one is going to be our first cut which is going to be all 13 millimeters. And it's going to be this region, this region. That's all for the 13 millimeter cut. Then we're going to do another cut for the second step. So you want to kind of think in terms of operations. If you were to go in, you would have to change drill bit sizes and things. That's kind of the approach that you're going to take. So we're now going to take these two from the surface, from this surface, and it's going to be, instead of 13, it's going to be that same 8. So that same 8 cut. All right. So we're starting to get some of the kind of unusual geometry here. And we've got our kind of big, ugly recess cut. So that's why we spent so much time on that sketch, was getting as much of that detail as possible. Because now this front half is all completely done. The back half, all of the recess cuts from the side are done. Now what we need to do is we need to do, it'll be easiest to probably do a sketch here on this front face. And there's a few ways that you could do it. In this case, I'm going to do the quick and dirty method. So that's going to be set a length, set an angle, close it. So now with my smart dimensions, I'm going to say this is 18. This is 20. And now I do an extrude cut through all. Yes, you could use some other taper features and things. This is going to taper some extra stuff, but we're going to cut out most of that anyway. So now I'm going to do a sketch starting from this top plate. I don't want to reference here, only because I'm thinking about doing a cut through the entire thickness of the part. So it's effectively going to be a rectangle. I'm going to reset view so things don't get super confused. I'm going to use origin, set my dimensions. Here, this is 12. And this whole thing is 50. So I'm pulling that from that second page, which is really the majority of what I need. And then there's the one more through hole, and that is going to be a circle somewhere over here. So I'm going to set this up. I'm going to set the dimensions. They reference this edge at 30, so not too far off. Diameter of 10. And they give the depth from this edge as 9. All right. So now I can do one last extrude cut. And it's going to be both of those. And it's going to be a simple through all. And there it is. So that should take into account all of the geometric oddities of the part. And we should be done. Because we'll have our chamfer, we'll have all of our other cuts, we will have our recesses at the bottom and on the side. And now we just need to set an alloy. So it's going to be copper. So not steel, copper. And this one, they specify just normal copper. So let's apply it. All right. So just normal copper. And let's see what our mass evaluates out to. So this gives us 1280.33 grams. So I would say B at 1280 grams is correct. All right. So, questions on this one?